Hello everyone. For this week's work in R, what I would like to talk about is functions, vectors, and packages. And these all really work together, and I'll go through the slides. There's about 12 slides here. The last two slides are actually things I want you to do in R and turn in for this week's exercises. But we'll talk about each one of these in separately, but you'll see how much they actually all work together. Let's start with functions. Functions in R are pretty much what we do. There's two things that we do in R. We load data, and then we conduct functions on it. So pretty much everything we do in R uses a function, or it's either in native R or it's in a package. The format is, you'll see in the second bullet point, is the name of the function followed by some set of arguments. And that's where the parentheses hold the arguments or the argument or arguments that are being put into the function. And we'll go through a lot of examples and you get to see how that works. Functions are specific tools that we can use to process data sets. And they're, again, either built into the application or found in packages. Here's an example. What we're doing is we're identifying a variable, even numbers, and we're going to set it equal to 5 numbers. Well, in order to do that and to do it correctly, we need to use a function called C, and C is combine. So what that allows us to do is it allows us to take those 5 numbers, combine them, and put them into that variable. Then, once we have that variable populated with that set of numbers, we can then run another function, that function mean, which is to calculate the mean of those 5 numbers. So we run mean on even numbers, that's the argument that we're passing to it, and it gives us a value of 6. It returns 6. Other functions could be things like median, where we could run median on those 5 numbers, and it would also return 6 because it happens to be the median as well. We could run plot. If we had two, for example, we had even numbers and odd numbers, we could run a function called plot, and that would actually take those two, assuming we had fed those in as arguments, even numbers and odd numbers, it would take those two sets of numbers and create a scatter plot for us. If we wanted to run something advanced like k-means, we can actually do that in R. We would just have to feed the correct arguments in, and that would probably be from a loaded data set, that one we had loaded in from a file, which we'll talk about in weeks to come. All of those functions require specific data and specific format in order for them to work. Let's look at another simple example. We've already looked at the combine function, so it's C, and then we feed arguments into that. And an example of that is in the second bullet point, where we're combining those 5 numbers into into something that we can put into a variable. So what we're actually combining those 5 numbers into is something called a vector. And vectors are incredibly powerful and incredibly useful in R. A vector is a storage mechanism for holding data of different lengths, different types, and different dimensions. And those are dynamically allocated as we load data in. So for example, we didn't have to do anything for the variable even numbers to tell it that it was going to have to hold one row of 5 numbers. We just combined the numbers and put them into that variable, and it dynamically allocated the space for all 5 of those numbers. So that's one of the most powerful things about vectors. Another most powerful thing about vectors is that you can run multiple functions on vectors regardless of how big they are or how they're organized. And R just sort of deals with it. R just sort of figures out what to do with them, and it's very, very powerful. So again, a vector is a storage mechanism for holding data of different types, lengths, and dimensions. It's dynamically allocated. The vector we created is 1 by 5, but we could have created 1 by 10, a 1 by 10 vector, or a 2 by 8, or a 5 by 5. Like I said, vectors are built on the fly to accommodate whatever data set we feed into them. So vectors are very powerful. Here's an example of some code in RStudio. And what I want to point out a little bit before we actually transfer this over to RStudio is that we have comments in our code that are indicated by the pound sign. So anytime R encounters a line that starts with a pound sign, it just ignores that line. So you'll see the comments are here, and of course, good programming protocol tells us to put comments in our code so that somebody along the line, or even you, 6 months from now, you want to see what you did in this particular line of code, you've got it commented and it's very clearly marked. Okay. What we're going to do in this particular script is we're going to combine the 5 variables into a single vector. We're going to assign it to a variable. We're going to display the variable, and then we're going to add up all the numbers using a different function. So let's go ahead and capture this code. See if I need to paste it in. I may already have it in RStudio. And I will close this version of it, don't save, and start it up again. And there's the script already put in for me. But what you can do is you can just paste it right at the first part of the editor, and it brings the script in. Then what I can do is I can go up to the very first line, place my cursor at the very first line, and I can run through the script command by command, right? So hit this one. I get to see that it has created my vector, and it shows me the vector. Hit this one, then I get to see that it's assigned my vector to a variable called even numbers. And what's more interesting is that down here where it lists out all my available data sets, it has added now even numbers. Even numbers is a variable that contains a vector. It has 5 elements, and these are the 5 elements. Okay, and that's something that I can keep and use in any one of my scripts as long as I need to. Go to the next command, and it's going to show me the variable. So if I just list out even numbers, it's going to show me what's in that particular variable. Then go to the final command, and I'm going to run into another function. This is the sum function. What the sum function is going to do is it's going to take all of the numbers that are in even numbers, and it's going to add them up. So go ahead and run that, and it gives us 30. And so we're done with our little script. Now I want to highlight the importance of what we just did. So functions can work functions can work on vectors, I should say, without having to loop. In many programming languages, if I wanted to do a sum function like I just did, I would have to go in and actually add numbers and then add numbers again and add numbers again until I ran out of numbers. But I don't have to do that in R, because the functions in R will interpret what it needs to do by looking at what the contents of the vector and just doing it all at once. So that's really powerful, because depending on the types of vectors that we have and the functions that we want to do, if R can just read the contents of the vectors and know exactly what to do and know exactly how to process them or deal with them or combine them, that will save a lot of time. Here's another example. This is a different vector. It's actually 2 vectors, and they're different, right? So the first names, I'm setting a variable called first names equal to the combine of Russell and Richard. Now notice that Russell and Richard are in quotes because they are text-based. The numbers I didn't have to put in quotes because they were numeric values, but for text-based values, I do need to put those in quotes. Then I can put the last names, assigned last names, to a combine of Wilson and Sherman. So I have 2 variables that have been assigned to 2 vectors. Now I can use another function called paste. And what paste does is it allows me to take 2 functions. I would specify in the argument of paste last names and first names, or first names and last names, and it will go ahead and produce the result by combining item 1 from one vector with item 2 from a second vector, and item 1 from the second vector, and then items 2 from the first and second vector to give me Russell Wilson and Richard Sherman. So that's just another illustration of kind of the power of vectors, in that I didn't have to write a whole bunch of code to combine those names. It did it for me, and it does that by assessing what's in the vectors and deciding what it needs to do. In the next example, in this case, I don't have even numbered vectors, right? I have 1 element in one variable, and I have 3 elements in another variable. So the first thing I did is I assigned first names, a variable called first names, to the vector that holds Peyton, Eli, and Cooper. See that those are in quotes. Then I come up with a variable called last name, and I don't have to do a combine function on last name because there's only 1 element in it. So last name will get set equal to the value of Manning. I can then run my paste. It will paste first names with last names, taking Peyton and merging it with Manning, then Eli, merging it with Manning, and Cooper and merging it with Manning, and giving me my results. So again, a dynamically allocated vector can be processed using functions within R without having to have R go through and figure out or freak out about the fact that it doesn't know what to do with the contents of the vectors. So the vectors are very powerful, and we will work with them a lot. Let's go back to functions a little bit and talk about some of the arguments in functions. We've already kind of seen this, so this is going to be probably a little bit repetitive, but most functions expect an argument. You can't just kind of put a function into R and expect it to do something. You got to tell it what it's actually going to operate on. So an example would be print. If you put in print with just empty parentheses, it doesn't know what we want to print, so it's probably going to throw an error. If we want to learn about the possible arguments, the things that we could feed to a particular function, we can always put the question mark before the function, and it will give us a list of all of the different arguments and all of the different uses of that particular function. A good example is in the 4th bullet point there, where I've got a question mark before print. If I do that in R, it's going to give me all the information I ever wanted to know about what I could do with print. So if you invoke, I already said this, if you invoke a function without specifying the arguments, likely it will throw an error. Print by itself will give you not an argument, it will give you an error. And then if you do print with hello world in quotes, that now has an argument and it will actually work correctly. Many of the functions that we use have print sort of built into them. So for example, that last bullet point there where it says print a combine of 2, 4, and 6 is really meant to illustrate that you can actually run a function within a function. And that's going to be helpful when we actually work through more R stuff. But it's a little redundant in the sense that if I actually did a combine of 2, 4, and 6, print is sort of built into the end of the combine function anyway, so it's going to print out those results just because the combine function worked correctly. But keep in mind, and this point was supposed to be that you could run functions within a function. Let's talk about functions and packages. Okay, as I indicated, R has a lot of capabilities. It has a lot of things that you can do. Many of the things that I showed earlier, such as sum and paste and C for combine, even mean and median, all those are things that are native functions that are built into the native version of R. But there are a lot of people out there who are writing really cool code for R. And while that's not going to touch the native function of R, the native sort of package of R, those things can be actually bunched together in something called packages. And packages are really extensions of R. They're similar to add-ins that you would have in Excel, where it expands the capabilities. It doesn't ship with the native version, but you can go out and get it from the web and you can expand the capabilities of the tool and be able to use those functions for other things. A good place to get those functions is from the CRAN site, which is a Comprehensive R Archive Network, and I've given you the URL there. But generally, you probably won't actually have to go there. When you do the install packages command, it will reach out by default to the appropriate place and download the package that you're looking for. I've given you 2 commands that are key. If you want to expand the basic capabilities of R, you're going to have to do 2 things. One thing you will do only once, and the other one you will do as you need it. The first one is to install the package. So the install package, when you find out what package it is you need, you say install package, you put the package name inside the parentheses within also double quotes, and it will go out and to the appropriate website, find the package, and bring it down to your PC and install that package. Okay, that's all great because now the packages are on your PC, but you're going to have to do something else. You're going to have to actually use the library command inside of your script to invoke that package and bring that package in and make the functions available to you when you're writing your script. So again, the install packages, every time you will only do that once. Library, you do it as you need it. If you're writing a script that doesn't need the functions that you downloaded in a particular package, then you won't need to do that. But if you are writing a script that does, then you'll want to do library, do it at the beginning of the script, and with the appropriate comments and the like, and then you'll have those functions available to you. Bottom line, packages extend the capabilities of base R. It just expands it to be a much more powerful tool, and you install them once and then use the library function to load them for a current script. Let's look at an example. Okay, so what if we wanted to produce a dot plot? Just say we had data set up, we wanted to produce a dot plot. Well, dot plot doesn't exist in the base code of R. It's not a function that's available. So without this package called Mosaic, we would not be able to use dot plot. Let me give you an example. I'll go over to RStudio and I'll type in, get on the right screen, and we get an error because it says dot plot is not found. So what I'm going to have to do now is I'm going to have to go out, and I know that I happen to know, and through research on the web you can find out where your functions are and what your functions contain and which packages contain them. I'm going to have to go out and do install packages, open paren, open double quote, and the name of my package is Mosaic, M-O-S-A-I-C. And it's going to go out and find Mosaic, and it's going to install Mosaic onto my PC, and it's going to give me messages that say, I just installed a new package. I put it into a directory, this one right here on your PC, and when you need it, it's going to be there. Okay. And the next thing I might do is library in order to be able to invoke the package, and it would just be similar to this the way you would have done the install packages. So now if I do dot plot, actually, let me do the library first. Library's loaded. Now if I do dot plot, it's going to throw an error because I haven't given it an argument, but you'll see that the function does exist. So that's the whole deal with packages, is packages allow you to extend R beyond the native sort of R functionality. And just a note on this, I did not put the double quotes in here. Install packages will throw you an error if you just put in Mosaic in the parens. I should have put double quotes in there. I didn't, but you'll see it. If you don't do it right, you'll see it that it will throw an error. But library doesn't require the double quotes. All right, moving on. What I would like you to do for this week's exercise is I would like you to take the script that I've given you in slide 4, and I will post these slides so you can just cut and paste the script right out of slide 4. Put it into RStudio and run it. And run it command by command, and just make sure you get the correct results. Just want to get you the feel of actually putting a command into the interpreter or into the editor, and then running the commands one by one. Then I want you to actually repeat what I did in the on slide 6 and 7. I want you to pick 2 people known to you, and set up the first names variable and the last names variable with a vector of the combined names, just like it does on slide 6. So you'll need to go ahead and combine the vectors then, after you're done, combine the vectors first names and last names using the paste function. So go ahead and do that and show the results of that. And then go ahead and pick 3 people with the same last name. You can pick any 3 people who have the same last name and repeat the exercise that I do on slide 7. Go ahead and set up the vector, do the combine of the 3 first names, and put that to a variable called first names. And then go ahead and set up the variable last name. Remember, you don't need to do the combine function for that one because there's only one last name. Run the paste function and see what you get. Okay. Next, go ahead and type dot plot on the command line and see what happens. You'll see that it's not going to work. Install the Mosaic package with RStudio. So that's install packages, like I showed you. And then add it to the library. Do the library function as I showed you on slide 10. And remember, the install packages, when you specify the Mosaic package name inside the parentheses, it must also have double quotes. Okay. Now try the 2 dot plot commands that I gave you on the end of slide 10. You should see that they work just like the way I showed you. Okay. So capture as much of that as you can and do by doing an alt print screen, and then paste it into a Word document at the kind of start of the Word document. That'll be the first thing you submit for this week. The second thing you submit for this week will be on the next part, which is this week's exercise part 2. In the first part, I basically have shown you everything that I need you to do. You're going to change the names, and that's fine. But in the first part of it, you're really just cutting and pasting code and then running it line by line. What I want to have you do, though, is I'm going to have you do a little bit more work on your own. First thing I want you to do is come up with a set of numbers, 5 to 10 different numbers, and combine them into a vector that you assign to a variable named numSetA. Okay. Then I want you to run the mean function on your numSetA so that you can determine what the mean of your numbers are. And then I want you to do the same for median. So I'm not going to tell you how to do it, but you can go ahead and see how it's done. Then I want you to come up with a second set of 5 to 10 numbers and combine them into a second vector that you assign to numSetB. Okay. Then what I want you to do is use the plot function to create a scatter plot of your 2 sets of numbers. I'm not going to tell you how to do that. You're going to have to figure the format out on your own. Okay. It's not hard, but you're basically plotting numSetA against numSetB. What you'll see is when you go into RStudio and you run that correctly, you will see a scatter plot appear in this particular viewer, which you then could, once it's there, export it as a PDF, export it as an image, whatever you want. But it shows you that when you have 2 number sets, you could combine them together into a plot, and then maybe that plot would be something that winds up being useful. Okay. When you're done with that, go ahead and do an alt print screen again of your RStudio and put the results in that same Word document that you opened for the part 1 of these exercises, and then go ahead and save that off and close that out and submit that as your submission for this week's exercise. So hopefully that all makes sense. I'm available on email if you have any questions.